Howdy everyone, my name is Griffin Furlong. I'm a professional engineer in the state of Florida, and in today's video, we're going to be going over grading of a commercial site. In this video, we have a 12.5 acre parcel that we're going to be looking at with a proposed 138,000 square foot warehouse. This has been a highly requested video, and I'm probably going to be splitting this into parts, so I guess welcome to part one. In part one of this little mini series, I'm going to be going over things that you definitely need to know before even trying to grade. And then I'm going to show you kind of how I'm going to start the grading plan. And before we get started, if you haven't hit that little subscription button, just hit it. It helps a lot. But I'm ready to jump into it, so let's get to it. Now, one of the first things you need to know before even trying to grade is number one, we need to have the existing grade survey. We definitely need to know the tie-in grades at the road connections and the boundaries. Now, the survey will be the main basis for the staking by the surveyor when they actually go out in the field. So this needs to be accurate. You can't just use random grades, especially if you're making construction plan level grading. So just to kind of put into perspective of where we're at, we've nailed down a site plan and we've nailed down the stormwater management of this property. The stormwater management is important because typically with at least Florida and where I'm from, a lot of these design levels, these design high waters of the pond will actually set some of the grades and the low points, but we'll kind of get to that later. Now, I mentioned the number one thing that you need is the existing grade in the survey. Now, the number two are your min and max slopes, and we need to know how these low points are set within the property. Now, typically these low points are driven by the municipality's design manual or the LDC, which is the Land Development Code, a traffic manual, or perhaps a drainage manual. You got to find it. It's in there somewhere. In this case, our low points are going to be driven off the pond's 10-year 24-hour stage. It's actually 10. So the 10-year 24-hour is at elevation 10, and that's NAVD. So per the land development code in this jurisdiction, any of these low points that we place have to be a minimum of the elevation 10. So wherever we place these little inlets or curb inlets, they cannot be lower than 10. That's very important because once you start setting some of these low points, you're going to be driving the high points, but we're going to get to that a little bit later. Now, I mentioned that we need to know how the low points are set, but we also need to know our min and max slopes. So in this case, our maximum slope that we can use is 4:1 max. And if you've ever seen any of my other videos, you might want to go back. I got some other grading videos that talks about this. So the max slope that we can actually have right there is 4:1, or also known as 25%. And that means there's 1 foot of drop for every 4. And I know that's kind of backwards when you see 4:1, but in this case with land development and how we show slopes, the 4 here is actually the horizontal, the 1 is the vertical. So that's the max slope that we'll be able to use in this development. The max driveway slope that we're going to have for this property is 10%. We're going to have a lot of truck traffic through here, so we definitely want to minimize the slopes going into this development. So again, if I was a truck turning into this development, I want them feeling less than 10%, going through that. Now, the minimum slope for these pavement areas are 2%. We want water to be able to travel to these low points, so we're going to be using a minimum of 2% to convey water to the low point there. And just for a little piece of advice, we're probably not going to get to it in this video, but we need to be very cautious of how we are laying out our ADA. We need to make sure that we're not going over the 2% because you can actually get sued for that type of stuff. So we need to be very cautious of how we're setting the grades around these areas where our ADA is. We're now on to number 3. So one thing that you really need to understand is the 100-year floodplain. You can get this from FEMA. This 100-year floodplain can drive your finished floor that we have shown right here. And I will show you actually how we were able to derive this FFE. Again, FFE is finished floor if you don't know. Always check your code in the regulations. Typically, your building FFE has to be anywhere between 1 to 2 feet above that elevation. But again, just consult your code. I'm not responsible for your design. This is all a fictitious property. Now, the very last thing that you definitely need to do before you even start grading is you need to have the stormwater management figured out. I already kind of mentioned that previously, But your stormwater can impact your whole site plan and grading. Let's say if I wasn't finished with my stormwater model and I needed more pond, maybe for treatment or discharge rates, or if I wanted to hold more back, well, that's going to start driving up all these grades, right? Because the higher your stormwater management is going, well, the higher all of these grades are going to be right here. And I'll show you how I've kind of set some of these low points. We have a very special case with this project on why the low points were set here, why the FFE was set at 15.6. So I kind of just want to dive in to some of those details of the driving force. All right, so now that we've gotten some of that stuff out of the way, we need to know where in the heck to start a grading plan. That's always the first question is like, I don't even know where to begin with this. Well, let me just say that every project is different. You have different sizes of projects. This is a 12.5 acre site. You have different codes, regulation, you have different existing grade or topography. You might have substantial amounts of drop across your property. It might be relatively flat. However, despite all of those things, I always start by analyzing the boundary condition. You need to know how you're tying in your grades to the boundary condition because you can't grade outside of that. You can't build outside of it unless you get some special agreements or easements from the other property owners. So, for instance, the first kind of things that I'm looking at is this boundary. And I'm just going to give it a little highlighter here. I'm going to go ahead and just highlight this boundary. So I'm highlighting this boundary in green. So again, that's the boundary. I cannot grade outside of that boundary nor build anything outside, again, without some sort of special easement or agreement. So I need to be tying my grades into that boundary. So the first thing that I do is I get my survey and I start understanding some of these grades along the boundary. When we receive the survey, we have figured out that some of the driveway tie-ins, which this is very important. We have our entrance right here. Let's focus on this entrance. These tie-in grades right here are 10, 10.09, and then 1021. So those grades right there. That's our existing road. We need to know how we're tying into our existing road. If we were to propose anything less than or above that, when the contractor and the surveyor go out there, they're going to be really, really confused about the tie-in, right? So we need to understand the tie-ins, and that'll be the basis of our actual entrance and all of the grading around. I see that there's a relationship here between the building and then this property boundary right here. So one of the first things that I like to do is I like to start understanding these cross sections. These cross sections are really important because it helps tell the story of the relationship between all of these grades. So one thing that we can actually start doing here is we can draw this cross section and just verify that we can catch our grading at the boundary. And let me go ahead and highlight that boundary again. Again, we're trying to understand if we can match our grade at that boundary. You can either work backwards or forwards. I'm going to just start from the building right here and draw a cross section to the boundary. Now, what we're doing here is we're verifying if this FFE actually makes sense. All right, so let me draw my cross section down here. So we have an FFE of 15.6, and I'm going to put these little breakpoints in here. That way you know exactly the relationship between all of these points. So that little line that I just drew there, that's number one. So that's like a little breakpoint right there. I'm going to show you how we keep analyzing this cross section. So everything kind of within here is actually just green space of what I highlighted. So that's green space. And again, we want water to flow away from the building. So I know that this is going to be sloping away from the building, and it's going to be, and I told you that the minimum percent that at least I want to use for this property is 2%. So we're going to be sloping 2% away from the building, and that's the open space and the sidewalk. So again, we kind of have this sidewalk right here that I'm going to draw in. I'm going to draw a little breakpoint here. That's number 2. And again, this corresponds to this guy right here, number 2. So again, we're sloping away from the building at 2%. So I kind of like to put some notes here. Now we can actually start coming up with some different grades here because we know that at the building is 15.6. And if we're sloping away 2%, and that's 10 feet, well, 2%, 10 feet, that's a drop of 0.2. An easy way to do that is do 0.02 times 10, and you get a 0.2 drop. So that elevation is 15.4. Couple questions to consider here, especially with your client, developer, or you, is are you going to have raised sidewalk or not? This could totally be a raised sidewalk, kind of as shown. You can park your car and it's a raised edge right there, or you can have it flush. Now, just a couple things to consider with this is, let's say if you have flush sidewalk, some municipalities will require a wheel stop. So, do you really want to buy a whole bunch of wheel stops here? Or do you just want to have the raised sidewalk? Now, some municipalities are different. You can actually avoid the wheel stops sometimes if you expand the sidewalk. But again, always consult your municipality. In this case, the client's direction was that they did not care if they have the raised sidewalk. So let's stick to the plan. And again, these are just some questions that you can begin to ask here. Now, with the raised sidewalk, any sort of curb or sidewalk, you'll have to verify, but some sidewalk can be 4 inches thick, some can be 6 inches thick. We're going to be specking out in this plan 6 inches thick, which is half a foot. Since we know it's half a foot, we're going to have a half a foot drop right there. So that's 14.9. And again, guys, we're still at that number 2 little breakpoint right there. Now, we've decided as the designer that we're going to just have inverted crown. Now, all that means is that inverted crown is this is the lowest point right here where I've drawn that blue, and everything is going to be grading to that flow line, to this flow line, and this longitudinal grade will be flowing to this inlet right here. Now, since that is the case, I'm going to put my third little breakpoint right here, number 3. And again, number 3 is right there. I hope this is making sense to everyone, but that's my little breakpoint. And again, if we're sloping down another 2% across a travel lane in the parking stall, let's figure out how much drop that is. So again, from this guy right here all the way down to this flow line, our parking stalls right now are 19 feet and our travel lane is 12 feet. So that's 31 feet. So 31 feet at 2%, everyone can do that math. Let's do 31 times 0.02. That's about a 0.62 drop. And I'm just, that's about a 0.62 drop. If that's a 0.62 drop, let's do some easy math there. And we know that that low point right there is 14.28. Now, what I like to do with this kind of stuff is I really just like to round. So a lot of times I will just round to the nearest hundredth. I like making this right here either a 5 or a 0 always, because we can't be perfect. Like, I don't think you're ever going to go out in the field and get a perfect 14.28. And we're talking 300ths here. So just kind of keep that in mind. So since this is inverted crown, from that number 3 breakpoint right there where I've shown, and we're going to be going back up actually the same distance in the same slope. Again, this is another just 31 feet right there. So we're just going back up the 0.62. So that grade's going to actually be the same thing on this side as it was on this side. So this 14.9 is golden. Now notice how we have a little curb here. I'm going to highlight the curb. So we have curb listed out right there. Well, we're going to be proposing, I believe it was D curb, proposed type D curb. This type D curb happens to be 6 inches from the edge of pavement to the very top. So I'm going to draw a little curb here, not the greatest looking curb. So that means that this top of curb right there is going to be half a foot higher than 14.9, which if y'all are starting to draw these connections, it's the same thing as this sidewalk over here. So that grade is 15.4. So this thing is really symmetrical here. I could have done that really quickly just knowing the distances between these lanes, but I wanted to show you how I'm thinking through this. So now that we've established that this grade right here, that elevation right there, we can understand how we're tying into this boundary at number 5. Number 5 is the most important. We need to know how we are matching our grade. So based on our survey, our existing elevation at that property line is 10, elevation 10. So I'm just going to draw that over here. We have to get down to this existing elevation right here of 10. Well, obviously, that's way lower than 15.4. So we have to make sure that we're meeting our minimum slopes here. So let's kind of figure that out. So we have to be able to slope from this point. I'm going to show 2 feet flat down to match that existing grade. And again, guys, we're trying to make sure and confirm that we can actually meet this existing grade at the property line. Because like I said in the very beginning, we have a 4-to-1 max right here. And what's, kind of eating into our slope is this 2 foot flat. We have to maintain 2 foot flat. We have 35 feet to grade from 15.4 to 10, but we have the 35 feet minus the 2 foot flat. So we actually have 33 feet. So let's do that math. Let's understand what that slope is if we were to make this connection. Again, what is this slope? Let's do 15.4 minus 10. So that's a 5.4 drop. So let's do 5.4 divided by 35 feet minus the 2 feet because we have the flat, guys. So divided by 33 feet. What's our slope? 5.4 divided by 33 feet is 0.16. So this is 0.16, also known as 16%, which is also the same as 6.25 to 1, roughly 6 to 1. So guys, we are meeting our slopes. Now, if this showed greater than 4 to 1, we would have some issues here and some problems that we would need to troubleshoot. Now, what that looks like is maybe, I don't want to do it, but maybe shifting the building, maybe using some steeper slopes, maybe sort of changing the design concept of not using inverted crown. Um, or maybe like a little retaining wall, but again, you're just adding cost to this system. So I hope this made sense. This is what I do when I am first looking at grading. I'm always cutting cross sections and I'm looking at the relationship of the building and other grading features to the boundary. Now that we know the importance of the cross sections and those types of relationships, I want to shift the focus back to the entrance because the entrance is really, really important here, guys. We've already talked about how this development is going to have inverted crown. All that means is if I were to take a cross section of this guy, that road is going to look something like this. You got this little travel lane, so these are like the little travel lanes, right? And water's going to slope away from that edge of pavement to the middle. So water sloping from the outside to the middle. We're having inverted crown. First thing that I'm looking at here is our existing grade at this tie-in is, let's just call it 10. Our lowest point that it can even be on this little inlet right here is 10. So we're going to have some sort of high point in between there to guide water to the necessary inlet. Now, the way that I'm kind of thinking about this is I know that this entrance is going to go up, this driveway entrance. I know that because I'm looking at this FFE of 15.6. I know that when I turn into this driveway, I'm going to have to get up in elevation. And even when I turn into this parking lot, I'm going to have to get up because I'm getting all the way up to 15.6. But one thing I also said is we really want to try to avoid a driveway slope at 10%. One place that I'd like to start here is I really just want to understand what kind of grades we're going to have right here because I know that it's going to be a high point. Again, we're going from the 5.6 down to the 10.09, 10.2. So I really want to understand my grades right here. That way I can kind of start working backwards and start verifying my driveway slopes right here and right here. So let's do that. We know that we're going to have a minimum 2% coming from here all the way down to this point right there. We also know that I'd really like to set a break point or a high point right here because I want to start collecting water in these inlets. Again, if you remember from the concept, this is an inverted crown. So this slope is going longitudinally there to that curb inlet there. So I really need to start understanding some of these grades that I've circled right there. So if I start at 15.6 and I knew that this is 10 feet at 2%, and this is 19 feet, and then that's the 12-foot travel lane. Well, I can start understanding what this grade could potentially be there and then, calculate a slope down and verify if that inlet is meeting the minimum elevation that I need, which was the elevation 10. So let's do that quick math right there. So how many feet do we have? We have 10. We got 10, we got 19, we got 12. 10 plus 19 plus 12. So that's 41 feet. So let's do 41 times 0.02. So that's about a 0.82 drop. A 0.82 drop from 15.6. Let's do that math. That's about 14.78. So for now, I'm going to call that grade 14. I'm going to go 7.5. Again, we're going to round here. So that's 15.6. I want to set a breakpoint right here at our 14.75. So dang, we're really climbing up there. Now I need water from this high point to start grading to this low point. 10 stalls, all with the width of 9 feet, so that's about 90 feet. Here it kind of goes back to some of our minimums and maximums that we're setting. So typically with longitudinal slope on an inverted road, we can be anywhere between 0.35% to 0.5%. And again, that's the longitudinal slope. It's not the cross slope. Do not get that confused with the cross slope. We are sloping from this 14.75 to this inlet. I want to use 0.5% because I really want water to go to the inlet. So with that, if I know that I have 14.75, I'm going to subtract 90 feet times 0.005 because 0.5%, you got to add two zeros in front of it. So this low point ends up being 14.3. And again, I'm just kind of showing you how we can start thinking about this. What's so important about this video, guys, is if I were to give this to like 10 different engineers, they would all have 10 different ways of grading the site. It just comes down to experience level, troubleshooting, coming up with different options and alternatives. But this is the way that we can actually start thinking about some of this stuff. We're going to have to tell the contractor that 14.75 grade and this 14.3. Now, a lot of grades that we'll have to put are typically around the point of curvatures or any sort of endpoint. And what I mean by that is I typically like to give grades here at those endpoints. Sometimes you can give grades here and there along the POCs, but sometimes it's just not necessary. Sometimes what you can do is just give a grade to right there, and the contractor will grade just right up to that point. So when this is all staked out by the surveyor is actually going to provide stakes at each of these spot shots that we give. So that's the importance of these grades that we're calling out. Each little grade that we call out is not just some random grade. No, a surveyor is going to go out in the field and actually place stakes, little wooden stakes with elevations of these grades. And the contractor is going to build it the way that we're calling out. So if this is the break point right here, I'm going to do it, let's say in purple. That's the high point. Water's flowing down to this inlet and then again flowing away from here, away from here. Well, we need to know how water is going on this other side. Where does water go right here? Well, if this is our high point, well, we need to start setting this low point of the inlet. We have to reduce the amount of on-site water that goes off of our property, which means, we definitely have a break point that we have to set before we're releasing way too much water from our property to offsite. Some counties are different. You might have to consult with them. In this case, we were allowed up to this point right here. So we've established our break point of right there. And when I say break point, I just want to be clear. That is also known as the high point. So, the one that I've highlighted there at the 14.75, that is also a high point or a break point. So all that means is that, water's coming out of that guy, and flowing away. This is roughly 60 feet from this point right here, all the way up to here, and this point all the way up to here. So we said that we wanted to maintain a driveway slope of no greater than 10%. So let's actually calculate what that might be if we were to set this high point close to the high point of the 14.75. So what I'm saying here is if we were to say that this is 14.75, Let's calculate that slope. 14.75. Let's use the worst case, which is 10.09. So that's a 4.66 drop. Okay. 4.66 drop across how many feet did I say? I think I said 60. All right. 4.66 drop across 60 feet is 0.077. So what I will say for that guy is a check mark. We have around, let's call it 8%. We have an 8% increase again from this driveway point that we're building new driveway up to a high point. So now we're getting up to this high point, but now we need to know where water goes to some of these other low points here. So how would I establish that? Well, I have this 14.75 here. I could go the minimum 0.5% down to this low point. That's something worth considering. But another thing I want to kind of consider too is the top of bank. Why do I want to know my top of bank? Well, I set that top of bank based on my design high water levels and the necessary freeboard. Well, I need to be able to make sure I'm tying in and that my grading isn't too steep or crazy around some of these grades that I'm putting. So let's keep that in mind. 11.43. So this top of bank right here is at a elevation of 11.43. I have to keep that in mind here. Now let me walk through this and make sure that this point 0.5 right here actually makes sense. So this is 100 feet between the 14.75 and the low point. So let's figure out what this low point grade is. So let's do 14.75 minus 100. It's 100 feet times 0.005%. See, that's not that much. It's not that much. 14.25. See, I don't love that. So what I'm seeing here is if I know that that point 0.5 is setting this low point right here, and if I need water to drain like this, it's going to make all of these curbs almost at like 14, 15 elevation, but my top of bank is 11.43 right there. That creates this really awkward transition. I got 15 feet and 11.3. So I kind of have to rethink this. And this is one of those moments where, you don't get discouraged. You just kind of have to start thinking about ways that you want to set these low points. So maybe we can just use a little bit steeper transition, and maybe that steeper transition can either happen from that 14.75 to this low point right here. Maybe it's just a longer transition, or maybe we transition down steep and we have a break point and then we transition softer. But really this isn't even too bad. So maybe we actually just have some intermediate break points here, because we definitely have to get down. So if I'm a car and I'm, going into this driveway here, I'm experiencing a driveway slope of 8%, and then I'm gonna go up is, let's just say, between this point right here and the 14.75, let's transition just a little bit more. Maybe we transition, let's try 5%. And that's gonna be 5% times 12, 30, about 30 feet. So maybe this is set at 13.25. And then from that point, we can slope back down to the low point, kind of at a softer slope. So if we're at 13.25 minus, we got about 70 feet left. Let's slope 1%. We're going to slope 1% right here. And again, we were saying 5% right there. So we're going to do the 13.25 minus 70 times 0.01. So that gives us a grade of about 12.55, which is way better than where we were at. We were at like 14. We're 2 feet higher, which this ends up being definitely a little bit better, because once we start grading these high points right here, we're going to be in a way better spot. So again, I'm going to zoom in and kind of focus on this area. We have the 12.55 that we got here, and we need to grade away to these points that I'm now going to be covering in blue just to show the focus. We're going to be setting these points. Now that we have the low point, when you have a low point, you can start grading to high points. That's how my focus is always. I'm always focusing on, okay, how do I get to my tie-in grade? How do I match my tie-in grade? And how do I start from a low point and go to a high point? Well, I know that I'm going to grade this whole little parking lot at 2%. So what I can start doing is I can grade 2% from here all the way up to here, from here to there. So I'm going to put these grades here in blue. So we have 12.55 plus, this is 12 plus 19 feet. So let's call it, so we got about 30 feet that we're grading, 0.02. So all these grades here are going to be set at 13.155. Again, this guy is 13.15, 13.15. So that allows water to drain from those higher points to the lower points there. I hope this video helped you guys understand what you need to even start grading. Like as we discussed, you definitely need the existing grade and topography. You definitely need to understand how your low points are going to be set, start drawing your cross sections, and then understand that floodplain, because sometimes that can end up driving your FFE. If you haven't watched any of my other videos, go check those out. I do a whole land development series where I walk through the design of a whole project. That's all I have for today, guys. Hope you learned something new. If you haven't already, hit that like and subscribe button, and I will see you in the next video. Peace out.
I be working 9 to 5, working 9 to 5, yeah, trying to stay alive. I be working 9 to 5, I be working 9 to 5.